Good evening and welcome to the Sunny Asset Tour. My name is Chris Schuring and I'm honored to be here this evening, and I want to talk to you about solar and alternative energy. And we're going to talk about how solar can affect your life, and we're going to talk about why you should do solar. And so before we get started, I want to tell you a little bit about me, just in case you're new to the program and you're just checking it out today. Again, my name is Chris Schuring. I've been in the solar industry for a while. Been in technology for quite a few years, going all the way back to the 80s, and been involved in energy now since about 2006 or so, and primarily in alternative energy and solar, and have been working on commercial and residential solar, and also some utility grade solar, and have helped plan and put some projects together in foreign countries as well. So I want to be able to kind of tell you my thoughts on solar and hopefully educate you. Tonight is about education. And if we can educate you and we can give you information and resources, then you can make an informed decision. So that's really my role tonight. My role tonight is to help educate you and give you the information so you can make those proper decisions. Now, one of the things we want to talk about today, we're going to have a little bit of discussion about myths, solar myths, alternative energy myths. What do we hear, and what's really the truth of what's out there in energy? Now, as I talk about these things and you listen to this presentation and you check out things online, I hope you do check out things online, because, or whatever resources that you might check out, because I only know what I know, and hopefully I can spur you to do some of your own research. And by doing some of your own research, you may find out things that I'm unaware of, and that's all good. That's all good. So we're broadcasting today from the New Life Worship Network.org, and we appreciate their allowing me and what I want to present to be on their network, and so I thank you for that this evening. As I go through this evening, I'll talk about some resources. So take some notes, write down those resources, and hopefully those resources will help you get educated. One of the ones that I use a lot is called DesireUSA.org. So that's DesireUSA.org. And what that is an online resource that allows you to look up all the incentives that are for alternative energy and energy creation and generation for not only consumers but for businesses as well. So if you go out there and see that website, you'll find resources allocated to what does PG&E pay for a new hot water heater? What does PG&E pay for new light bulbs, if they do at all? So go out and check that site out. Not right now while I'm talking, because I want you to take notes of what we're talking about, but write that down and go check it out. So let's start off with some of the things that I hear people ask me about solar. Now let's see if we can get into maybe some of the truth behind it. So even yesterday, I was talking to a gentleman, and this person, a very intelligent man. He does a lot of things in business, and he's actually part of the solar industry. He's doing things in it, but he's not as informed as he should be. And he made the statement to me that don't you have to upgrade your solar panels on your house every 5 or 6 years? And I asked him, well, what made you come to that conclusion? And he really couldn't answer the question, and that's okay. I hopefully informed him so that he now has more knowledge. And he said, don't you have to do that? I thought they got wore out. I thought solar panels wear out, and in 6 or 7 years that they would wear out, and that new technology would come on board, and we'd want to replace the solar panels that we have on our roof so we get new technology. I said, well, In actuality, most, I can't say all because there are some that are not, but most solar panels that you see installed come with a 25-year manufacturer's warranty. Well, when they come with a 25-year manufacturer's warranty, that pretty much tells you that the manufacturer and the insurance companies who back those things believe the solar panels will function and operate to the capacity of which they were purchased to do for at least 25 years. Now, do you have to replace them? If they break, you do, or if they fail for some manufacturer failure, you do. But that's different than just replacing them because you thought they wore out. Solar panels themselves actually have no moving parts. So really the only thing that diminishes the capacity of a solar panel and makes it so that it's not as functional as it was when it was purchased is that we allow the glass to get dirty. Much like this podium, if we allow the glass to get dirty on this podium and we can't see through it any longer, how do we replace it? We wash the panel, we wash the podium. And so solar panels are the same way. So they won't wear out. They will function as they were designed to function for quite a while. The example I use is I have a watch on. This watch is driven by light. I can't say just solar, but it is driven by light. I purchased this watch about 14 years ago, maybe more. But I purchased this watch 14 years ago, and yes, there is new technology available. But the fact of the matter is, the watch still performs the function for which I purchased it for. Still tells time, still accurate, still works, still fits on my wrist, that kind of thing. It does what I purchased it for. Solar panels are much the same way. If you purchase them to produce 300 watts of power, 10 years from now, they're going to be producing power. They may not produce a full 300 watts, but they're going to produce power, and they're going to produce the power that you need, that you purchased them for. So you don't have to replace them. In that discussion, we talked about technology upgrades as well. We talked about whether or not in 3 to 4 or 5 years do we need to buy new solar panels because there's new technology on the market. I talked about this in a previous discussion, that yes, there are advances in technology in many, many things. There are advances in technology in solar panels. But the advances in technology of solar panels that you see in the consumer market, the ones that are put on your roof to produce power, are very slight, maybe 1 or 2%, if at all, in their actual performance over time. What has improved in solar panels is the manufacturing process. The manufacturing process has gotten better, operational costs have been lowered, and there are a lot of robotics involved. And so solar panels have become cheaper, and maybe their efficiencies have gone up by 1 or 2%, but it hasn't been by huge leaps or bounds, right? Now there are other technologies on the market in solar and alternative energy that are very cool. Concentrated solar, they have solar panels that have lenses on them so that they concentrate the sun so that you get more power out of them. And these are all very cool technologies that have been created, and you see news reports about them, but they're not in the consumer market. So you won't see them on anybody's roof. The reason is because it isn't that they don't work well, but the banking and financial institutions and construction institutions and so forth have not adopted those technologies as technologies that they want to embrace either financially or operationally, so you don't see them in the consumer market. You might see them in the consumer market in 5-10 years from now, but you're not going to see them anytime soon. And when they do come in, they'll be very slow to be adopted because of those characteristics, finances and otherwise. So that kind of the long-winded story of do you need to replace your solar panels every 5 years or so? No, you do not. If they break, we suggest that if you're going to put solar panels on your house or your business, that you have a discussion with your insurance company and make sure that you have an insurance policy that covers property loss, right? And that property loss, if you have the right insurance policy and somebody gets up on your roof in high heels and breaks all your solar panels, then that should be covered by an insurance policy. And if they fail because of manufacturers, they'll be covered by the manufacturer's warranty. Okay. Here's an interesting one that people have brought up on very rare occasions, but I think it's kind of humorous sometimes. And that is, somebody asked me, well, the moon is really bright at some times of the year. Will the solar panels actually produce electricity from moonlight? The answer is no. Just kind of short answer, no, it will not. The moon is actually a reflection of the earth, not a reflection of the sun. And so you're not going to get any electricity generated from that. The other is that the sun that powers the solar panels, as it goes and powers those solar panels push the power through what's called an inverter. And that inverter takes the power and changes it from DC to AC. And that inverter typically will have some settings in it that says that when the panels start to produce a certain lower quantity of power, it will actually turn the inverter off because it's no longer producing enough power for the inverter to work efficiently. So once the sun starts going down, if this is a solar panel and the sun's over here and the sun's hitting that solar panel, you're going to get power. But when the sun gets over here and it's not hitting that solar panel anymore, you're not going to get any more power out of it. Okay. The good thing is that there are technologies that have been used on the glass surfaces of solar panels to help refract and reflect the light as it hits the solar panel and enter into the solar panel so they can get better efficiencies. And those are the 1 or 2% that you see when they've modified the glass a little bit. Okay. The other thing we want to talk about is trackers. And this is a little bit of a technology talk on that. Trackers are devices that solar panels are attached to, and when they're attached to trackers, the trackers will follow the sun. And when it follows the sun, you get more efficiency. And so if it's pointed at that light up there and the light moves, the tracker moves with the light, moves with the sun, and so you get better efficiencies. There's things called a single access tracker and a dual access tracker. A single access tracker moves in one direction, and a dual access tracker moves in two directions. So it follows the sun and the horizon. I'm not very good at the whole two-handed move thing, but it moves in two directions. So you get more performance out of it. And the reason why I bring that up is I had some people ask me, well, can I put a tracker on my roof and so I can get better solar power generated from my solar panels? Can I put that tracker on my roof? And the answer to that is no, you cannot. There are people who have and are still working on trying to develop a tracker mechanism for a roof, both commercial and residential. But the challenge is that the pressures put on the structure for doing a tracker and the wind resistance and those kinds of things and the inability to ballast or secure those trackers to a firm device have prohibited it currently. I'm sure somebody will come up with a great design, but currently it prohibits the ability to put a tracker on your roof, because when if you were to put the tracker on the roof of this building and it were to start to move, there is a high likelihood that it would actually, because of the forces and torque required to make that happen, it would actually tear the roof right off the building. So you'd have a tracker, but you would have no roof. So they haven't developed one. So you cannot put a tracker on your roof currently that works, right? You can put it up there, I suppose, but it's not going to work, and it's going to weigh too much. So talking about weight, when we put panels on a roof, sometimes the question comes up, will my roof handle it? how much do solar panels weigh, and will my roof be able to take the weight? Now, we can never always say, it doesn't sound right, but anyhow, we know that there's a large majority of roofs that the solar panels will not have a problem with. They will add anywhere between 3 to 4 pounds per square inch on the roof, and that's generally acceptable. I've worked on roofs that were built in 1929 on a commercial building. Panels were fine because the underlying structure was very strong, and so it was not a problem. I've worked on aluminum or steel buildings on some projects, and the steel buildings were brand new. They were built in 2002, 2003, brand new steel buildings, very nice buildings, but they would not hold the solar panels because of the way the construction was done and the price of steel. They used a lesser quality steel, and so the weight coming inbound on a roof would not support the solar panels without additional engineering to support the structure of the roof. So there are instances when it won't work. Very few, far between. And the ones that I have come across that the weight was a problem on the roof, we were able to augment that by looking at some other structural integrity items on the roof, like maybe running a cable or something else. And of course, those are additional costs that you need to take into account. So the weight should not be a problem. I weigh 235 pounds. I can walk on a roof, not a problem, right? We're talking about a solar panel that weighs about 42, 43 pounds over a 3 by 5 area, 15 square foot area. That weight is distributed, and it'll be between 3 to 4, maybe 5 pounds per square foot that it applies to the roof, so it shouldn't be a problem. When it comes to roofs, we talked about this before, and we talked about using good quality contractors, good quality installation crews, and those kinds of things. That there are different ways to install solar panels on your roof. Number one, you can do what's called a penetration. So what they're going to do is they're going to go to your roof, they're going to find a joist underneath your roof, and they're going to put some sort of anchor, either a bolt or a screw or some sort of plate that goes into that joist. And they're going to penetrate your roof to put a rail on and put the solar panels on top of it. The other is they can do a ballasted, which means they're going to put something on your roof that has a weight to it. They're going to use bricks or gravel or something else to weight that mechanism, and then put the solar panels on top of that mechanism. So it's penetration or ballasted. Now, when it comes to both of those, there are some pros and cons. The pros to ballasted is that you don't have to penetrate the roof. The con is it weighs more, right? It's used mostly it's going to be mostly used in commercial projects. Very few residential projects have I seen ballasted used on unless it's a flat roof. So if you go to some houses that have flat roofs, you're going to do ballasted. You're not going to do a ballasted on this building because it has a pitched roof, and the ballasted is going to fall right off the roof. So you will see that on some commercial buildings, and there's lots of different people who make ballasted systems. But it adds more weight to the roof, so you got to be aware of that. And there are a lot of jurisdictions still today, even though it's fairly popular, still a lot of permitting organizations that won't allow them to be placed on a building. So you can go and say you want to do that, but if you go to pull the permit, and all these projects we talk about need to have permits pulled for them. When they pull the permit, the permitting agency may say, you can do ballasted, but what we want you to do is penetrate for the ballasted. So you kind of lose the whole effect of having a ballasted system because they want you to penetrate the roof because they're afraid it's going to fly off. And so what they're going to do is they're going to have you penetrate it. Now, you're going to hear a term when it comes to roofs. It's called either penetration or minimal penetration. Fairly obviously what they mean, but what they'll imply is some racking systems only have a span of 6 feet or 4 feet. And so you need a penetration every 4 feet. Some racking systems allow you to go 20 feet, so you have less penetrations. And so minimal penetrations mean fewer holes in your roof. Now, when I talk to people, whether it's in business or your general residential consumer, and I talk about, hey, we're going to put holes in your roof. How exciting is that? We're going to go up there, we're going to drill holes in your roof, and we're going to put solar panels up there. And not all the time, but there's a lot of people that say, whoa, 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 you're not going to put holes in my roof. Well, this is again getting back to where it's important to get a good contractor and a good quality installer who's done it before, because in most states, they're going to have to warranty and guarantee that penetration not to leak for the next 10 years on your roof, according to building code. So the people who are putting the holes in your roof need to have the right licensing and the right warranties and guarantees, and maybe even a bond that says they know what they're doing, they've done it before, and they stand behind their work. Because every once in a while, I've seen some projects where everybody did the best they could. Everybody did everything according to code, did all they could, and it still leaked. So what happens then is the contractor is responsible, has to come back and fix that leak, whatever it takes to fix that leak. Now, they don't want to have to come back and do that, so hopefully they do a great job to begin with, right? Okay, a little bit more on roofs, getting back to maybe I don't want to say a myth, because it has happened from time to time, but when you look at the quantity of solar systems that are installed on commercial and residential roofs, the amount of times that this particular instance has happened is fairly rare, fairly minimum, and I think that there is still some discussion around how it actually happens. But I was just talking with someone the other day, and they said, well, if I put solar panels on my roof, won't it catch my roof on fire? Won't my roof catch on fire, my house burn down because my solar panels are on the roof? If, again, they're installed properly, and they're installed by licensed technicians and people who know what they're doing, I think it's an extremely rare case that that's ever going to happen. There's only 3 that I've ever actually heard of that I actually followed up on and were able to confirm that there was a fire on the roof. And the 3 that I followed up on, it had to do with faulty installation and faulty wiring, not the solar panels themselves. Okay, solar panels were part of it, but it's like saying I got a new refrigerator and I plugged it in my kitchen and the wall jack burned up in my kitchen, so therefore it's the refrigerator's fault. Now, I could be wrong, and there are times that things go wrong. So I don't want to say that it never happens. But extremely rare. Extremely rare, and the ones, like I said, I followed up on, it was because they were installed improperly, and there were bare wires, and those bare wires were touching the roof, and solar panels do generate electricity. Electricity is heat, and when there's a short in electricity, the heat is intensified, and fires happen. Now, what you'll find is there's a lot of new regulations around this for firefighters. So when I look at a roof, and I'm going to illustrate again on the podium here, mostly for myself, you really can't see what I'm doing, but if this is a roof, on this roof, the firefighter is going to require a walkway on the top and a walkway down the side, so if there is a problem on the roof, they can get up there and take care of it, and they can get to it without having to walk on the solar panels. So when you see illustrations and or pictures of solar systems on roofs that cover the entire roof, top to bottom, eave to ridge, and side to side, either those are older installations or they're installations in other countries. Because in this country, 99% of the installations are going to require access for firefighters, so if there is a problem, they can get to them. Give you an idea, we did an installation on a commercial building, and it had skylights. Pretty cool, it had skylights on the building. A lot of buildings these days have 10 or 15% of the roof are skylights, so they get that natural light in there. And we actually had to install an air line up to each one of those skylights that had a capsule in it. So if the fire department came in and there was a fire in the building, they could hook up a high pressure air nozzle to the line down on the street level, and it would go up and hit all those solenoids and blow all the skylights out. So it would vent the fire so the firefighters wouldn't actually have to get on the roof. It was very cool. It cost a lot of money, but it was very cool stuff. So all that being said is that if you're considering doing solar, which you should, if you have a flat surface and the sun shines on it, put a panel on it. But if you're considering that and you have any concerns about that, call up the local planning commission. Call up the local planning department. Hey, I have a house. This is where it's at. This is what I'm looking to do. What do you think I should do? Who should I talk to? Those kinds of things. Just so that you feel comfortable, because just like this discussion is called the Sunny Asset Tour, the idea is you're putting solar panels on a roof of a building that is your asset. And the solar panels want to produce power so that they are also an asset. There's lots of financial planners that tell you if you're going to invest in something that generates money, that is an asset, a product and a process that creates money. You just don't lose money, right? So a car, unless it's like a 1962 Corvette Stingray, a car is not really an asset because it depreciates in value quite rapidly, whereas a solar panel, it produces money, so it's an asset. So if you're going to put that on your roof, if you're going to put it on your asset, just be aware that you should take care of those things, okay? All right, so we talked a little bit last time about maintenance. And so I'm just going to touch on that real briefly. Some people will ask me, hey, I was talking to somebody just the other day, they're in an agricultural area. There's lots of farming going on and those kinds of things. And they said, how often do we got to clean these things? And how do we do it? And this happened to be on a building that was over 2 stories tall. I said, how are we going to do that? I said, well, one is, if you get up on the roof and you're going to wash the panels, always do it either really late at night, which I don't recommend necessarily, but I do recommend first thing in the morning. Because the surface of a solar panel, especially here in California, a surface of a solar panel in the middle of the day can get to be about 140 degrees Fahrenheit. Last thing you want to do is put any kind of solvent or cleaner or water on that glass, okay? So you want to clean them first thing in the morning. What do you want to clean them with? Clean water and a squeegee. And all you're trying to do is get the dust off and keep them clean and those kinds of things. If you're in a high dust area, you might find that along the lower edge, because you have glass that has a frame around it, or along the lower edge, we did a project out in a rice field, and part of the problem was that the rice kernels from processing, the dust and things from the processing, would actually get stuck in that aluminum ledge. And so they had to have a little extra effort to clean them out. They used a pressure washer, fairly low pressure washer, to get those things out of there. And that's how you should clean them. Most residences in a lot of areas, your natural rainfall is going to clean them a lot. Most installations these days have a monitoring system of some sort. If you have a monitoring system on your solar panels, you can look at that system on a regular basis and start to look if your panels are not producing the power that you think they should be producing. You should get up there and take a look and see if they need to be cleaned. Now, if it's on a second story or you can't get to it, or you feel uncomfortable getting up there and cleaning them, that's okay. There's a lot of people, including myself, I have no business getting on a roof. I have no business climbing on a ladder or getting on a roof. It's not what I do. But there are lots of window washing companies out there now who actually wash solar panels just as well, right? They got the tools, they got the gear, they got the insurance, they got the ability to get up there and clean those panels, right? It's going to cost you a little bit of money, but you got electricity and you're making money off that electricity, so you should maintenance it just like everything else, right? But please use a professional when you're getting up on a roof, okay? Lots of things can happen. If it's not your line of business, you should stay out of it, right? Let somebody else take care of it for you. So anyhow, so maintenance is fairly simple. The only other part of a solar system that might need a review and a maintenance, and that is the inverter itself. Inside the inverter are some electronic components, a couple capacitors, depends upon the manufacturer. Got some stuff in there that takes the DC power and turns it into AC power. On the top of those capacitors inside that box, there's some fittings and so forth. And sometimes, because of the vibration of electricity, those fittings may come loose a little bit. And when they come loose a little bit, they generate heat. And that heat means you're losing power. So I would recommend at least once a year have just a general electrician, nobody big and fancy, doesn't have to be, guys with 500 trucks. Just have a general electrician come out and check your inverter. Make sure it's operational, check it out, make sure there's nothing loose in there. I recommend that once a year. The manufacturer may say, hey, you don't need to do that for 4 or 5 years, but I personally recommend it once a year. Spend the $100, have somebody come out and just make sure that thing's operational. And other than that, you're good to go. The solar panels run on copper cables, and copper cables don't wear out, and the junction boxes don't wear out, so you should be good. Now, I want to talk a little bit about inverters. And I'm not sure I covered this territory before, but I want to talk about inverters, part of the technology of solar systems. In my next talk, I'll have some graphics and some slides, and we can take a look at some of these technologies, the visuals of some of these technologies. This evening I just wanted to have a conversation, and in this conversation hopefully I can help you ask questions. This video will be posted, and please don't hesitate. Every once in a while my email address is flashed up on the screen. Don't hesitate to send me an email. I get lots of emails, but I try to answer every one of those emails that has any value to it whatsoever. If it comes from a client or customer or one of the viewers, I see value in that, and I will respond to that email. So next time we'll have some slides and maybe some puppet shows and things like that. We'll do something fun. Anyhow, so let's talk about inverters for a moment. There's a couple different kinds of inverters on the market, and the main reason I want to talk about this is so that you can understand a little bit of the technology description and why they are the way they are. Okay, so first we're going to start from the biggest to the smallest. The biggest is what's called a central inverter. A central inverter can be the size of a couple of large refrigerators. A central inverter can be pretty good size. It can be as big as 8 feet wide, 6 feet tall, and weigh 5,000 pounds. Or it can be as small as a stereo cabinet. But a central inverter is designed to take an array, which is a series of strings, into one central location to convert the power. So it's going to take all the solar panels. They're put together in a string called an array, and they're going to take it down to one central piece of equipment that takes it from DC to AC power. Great. They've been out there for a long time. They work great. I'm going to tell you a little pros and cons on both, okay, on all these. Pro is they cost a little less because you got one piece of equipment. They cost a little less. The con is they're heavy. A central inverter can weigh a couple thousand pounds and could be as big as a refrigerator. Not necessarily for your house, but could be, right? Could be large. So you got to allocate space for that and those kinds of things. The other con is that if you have all of your solar panels in a string, they're all put together in an array, and they go into one central unit, you have a single point of failure. If there's any problem in any one of the solar panels, because they're all hooked together like a big circuitry, if you have a failure in any one of the solar panels, you could lose power from your entire solar array because they're put in series, like a circuit on your roof into a central inverter. If you have a problem with one panel, you could lose power from all of your system. Those are the cons. Again, the pro is they're cheaper, readily available, been on the market for a long time. If we move up from that, we have what's called a string inverter. And a string inverter says that I'm going to take one string of solar panels, maybe 8, 9, 10, 12 solar panels, and I'm going to put that into one inverter. I may have 6 strings in my array, and each string would have an inverter at the end of the string. So that's called a string inverter. Okay. Pros to that is they're fairly lightweight, fairly small, easily to be installed, easily maintained, been around a long time, they work really well. And if you have them and you've got 6 strings and one of your strings has a failure, the other 5 strings still work. So if you have 6 strings in your array on your roof and one of the strings fails, you still have power being generated from the other 5 because they're independent of each other. So that's a string inverter. The con to a string inverter is they can be a little bit more expensive and you've got to buy more of them. So let's say a central inverter costs 19 cents a watt. The equivalent string inverters might cost you 23 cents a watt. It's not a huge number, but when it comes to the finances of these things, every penny makes a difference. And so the engineer who designs these things needs to be aware of these cost components. So when somebody talks to you about doing a solar program, either commercially or for your residence, and they say, well, we're going to use string inverters on your strings, and we're going to do 6 string inverters for your array, I want you to be aware that there's a good reason for that, and there's a bad reason for that. The bad reason is it's going to cost you more, right? It's a little bit more pieces of equipment. You're going to have maybe a little more maintenance that you have to be aware of, because instead of having 1 unit, you've got 5 or 6, right? I like string inverters for a lot of reasons. It allows me to control my arrays much better so that I don't have a failure rate quite so high if I have a problem. But again, they cost more, right? So you got to balance that against what your goals are and what your finances are. The next one is called a microinverter. Microinverters have been on the market now, I'll say, maybe 5, 6 years, something like that. Really strong in the last 4 years. And what microinverters are really cool. I like microinverters. I think they perform a great function. And there's a couple companies out there that are really strong in the microinverter space. The pros are, now instead of having a string inverter on my string, if I have 12 panels in a string, I now have an inverter on each panel. So each panel has an inverter for each panel. The benefit of that is, I'm looking at a bunch of seats here. The benefit of that is that this center seat right here is getting a lot of light. Let's assume that's a panel, right? The ones behind it are not getting quite so much light. Well, when you're using microinverters, you're generating power on a panel level. You're controlling your string and array on a panel level. So if you have a panel at the end of the string and it gets shaded by your chimney or a large duck or a cat or whatever, and it's shaded down here, the rest of your panels still work. They still work. If it was a string inverter, those panels are, that whole string's done. If it's a central inverter, that whole array is done. Microinverter, it's on the panel level. So you can control each panel. The good thing about microinverters can be, because you can control that and you'll have a good steady output of electricity even though you may have a few panels that get shaded. They're out there. There's a lot of manufacturers now. They're tried and true. They work really well. Cons, they can be expensive. So if we talked about 19 cents and 24 cents, a microinverter may cost you 30 cents. And when I say cents, I mean by watt. So if you bought a 300 watt panel and you put a microinverter on it, that microinverter is for a 300 watt panel. So take 30 cents times 300, and that's what that inverter would cost you, right? Again, getting down to finances, just making sure that if somebody comes to your house and you live in the Central Valley, California, hasn't been a tree in your yard for a century, you have a roof that gets baked by the sun all year long, there's no reason for you to do microinverters, none whatsoever. Because you're not having shading problems. There's not a differential about which panels are getting shaded by chimneys and birds and trees and clouds and those kinds of things. If you live up in the mountains and you get intermittent shade because of trees and the way the sun goes around, microinverters might be a good option for you because you're going to have a better system. So these are the things that when you go and you look at, somebody says, hey, Bill, I'm going to come out and do a solar system on your house, and we're going to use string inverters on 300 watt panels. I want you to be aware that there's a need for them, and there's a time when you don't need them, okay? There's some new inverters coming out on the market now that I want to talk real briefly about, and I like to call them, they call them microinverters as well, but I like to call them macro inverters because it's easier to explain. So I'm going to back up a little bit just so we have a progression, okay? Central inverter, whole array. String inverter, a string in an array. Microinverters, panels in a string in an array. A macro inverter, 4 panels in a string in an array. So there's 1 inverter for every 4 panels. Benefit, same benefit as a microinverter, because you're controlling 4 panels, not 12. So you have the same benefit of a microinverter. It costs less than 4 microinverters, but has the same benefit. Maintenance is less because it's solid state. The ones that are coming out are solid state. There's no moving parts in it. And the ones that I've been looking at actually do a really good efficiency of going from DC to AC. So macro inverters, you're going to see those on the market. They may call them macros, they call them micro inverters X, micro X inverters. There's a couple of names that are coming out with them. But those are inverters that do like 4 panels. Your typical string is going to be 6, 8, 10, 12 in a string. And so these are going to go in and do 4. Currently, these macro inverters are being used in off-grid situations. They're being used in a lot of off-grid situations where they're only going to use 3 or 4 panels, right? Powering a cabin at night, not at night, in the moonlight, right? Remember that? No moonlight. So they're going to use those in off-grid situations. The ones I've been looking at, they take 3 panels, hook it up to the macro inverter, and the 4th junction coming out of the inverter goes to a battery bank, and it charges a battery bank. And now you have off-grid solar. Okay, so those are inverters. When you look at inverters, excuse me, the key component of looking at an inverter is its conversion ratio. There are some inverters that come from foreign lands that their conversion ratio is as low as 85%. In other words, all the DC power that comes in, 15% of it is lost in the conversion. You can get those inverters really cheap, really inexpensively, but you're losing a lot of power in that conversion, so is it really cheap? Probably not, if you really look at it. Some of the better brands of inverters could have as high as a 90 or 92 or 94, I've even seen 95% conversion factor. So that means when I go from DC power, the sun into a solar panel, DC power into AC power, so I can power these lights, I'm only going to lose 5% of that power. And so when you look at these things, I don't really like to get really technical in what we're talking about, because I could spend 2 hours on one technical aspect of energy. And most people would fall asleep within 32 seconds, okay? Because it's just boring. Well, you know, what can I tell you? It's boring. But it's necessary. So again, if you're out there and you have a house and somebody says, I want to come up with solar panels on your roof, any manufacturer that's involved in the energy industry has a specification sheet. And that specification sheet will explain all of these things. Now, it'll explain a whole bunch of other stuff that, frankly, at the consumer level is nothing but confusing. You know, sine waves and all these other kinds of things. But ask for those spec sheets. If you're going to put a panel on my roof, I want to know what the panel manufacturer is. What's the warranty? Right? I want to know what the conversion ratio is. When you buy a solar panel, you buy a solar panel because of the nameplate rating on the solar panel. So in respect to that, I may go out and buy a 300 watt solar panel, and I may pay 60 cents a watt for that. So that means I'm going to pay 60 cents times 300, and that's what that panel costs me. But if you look at the spec sheet will tell you that that panel is plus or minus 5%, 10%, 15%. So what that means is that solar panel is only warranted and guaranteed to produce power within a range of 5% plus or minus. Right? Very rarely, and I can't say that never has happened, I've never seen a panel that's plus. So they're guaranteed plus or minus 5%, plus or minus 10%. I've never seen one say, oh, it's plus or minus 10%. By the way, we generate 10% more than we said we were going to. It's generally the other way around, okay? So you want to look on those spec sheets, because you can look at a spec sheet and you can say this panel looks good, smells good, tastes good, because they all look alike, right? They're all very similar. They're all 3x5. They're all glass. They got black stuff underneath or blue stuff underneath, and that's it, right? What do we know? They got white on the back. But if you look at the spec sheet will tell you whether it's plus or minus 5% or 10%, right? Because you're paying for that 10% whether you like it or not, both in the production value and the actual cash out of your pocket, right? So ask for those spec sheets. Now we're going to wrap up here in about 4 minutes or so, and I want to talk just briefly about finance, and then we'll wrap up for the evening. I appreciate your time, and I appreciate you listening to me, and I hope I was able to instill some sort of education or knowledge to you. If you're in California, look up Go Solar California. Go to the website. The government has a great website, a lot of great resources. So Go Solar California is out there. You should look up those websites. Look up Desire USA, DSIREUSA.org. If you look up NREL, the National Renewable Energy Laboratories out of Golden, Colorado, nrel.gov. Now it's kind of in their website somewhere, because National Renewable Energy Laboratories works on a lot of things, but they have a part of their website that's very cool. It's called In My Backyard. And you can go on that website and you can put in your zip code and your expected usage of power, and they can give you a ballpark of what solar systems are being sold for in your area. They can give you a ballpark of how big of a solar system you might need, those kinds of things. So it's called In My Backyard. Do some research. When you go to buy a solar system, somebody somewhere, whether it's you, the financier, or somebody, is investing serious dollars in that system. Let's make sure that we do it properly. And let's make sure we do it with good education so we can make those informed decisions. Real quick on financing. A lot of people get concerned about the financing, and you should. It could be a $10,000 or $20,000 investment for somebody, and you should be concerned about financing. The great thing about, I'll talk about residential and consumer-based versus business-based solar systems these days, is the financing has been simplified in a great way. So if you're going to finance a system yourself, call your bank. A lot of banks these days, even credit unions I've talked to, have great financing programs for solar. The PACE programs. For a number of years, there were PACE programs across the United States, and the PACE programs are great for financing solar. They went out of favor for a while. That's about a 20-minute talk of why they went out of favor, but they went out of favor for a while, but they're back. And it's for doing renewable energy and energy retrofits and so forth on your house. And there's even an option for commercial properties. And that is Property Assessment for Conservation of Energy is, I believe, what it stands for. Type it in and Google it. You'll get all kinds of information. You'll find out whether your neighborhood or jurisdiction has PACE programs. What it allows you to do is put solar system on your house, and your house physically actually buys it, not you, which means that it goes on your property taxes. The benefit of that is if it's on my property taxes, I write off more on my property taxes. I have less to pay on my electrical bill. My electrical bill goes away. It's now on my property tax, and I don't have to use my credit rating to get it. It's based on the house. So PACE is great. There's lots of finance companies out there that finance PACE programs. So check out those finance opportunities. There are things called PPAs. PPAs are power purchase agreements where we put solar panels on your roof. You buy the power that's generated, all good. The solar panels and all the system are the responsibility of the people who bought it, not you. You're just buying the electricity, which means they cover all of the maintenance, they cover all the warranties, they make sure it works, because if it doesn't work, it doesn't generate electricity. It doesn't generate electricity, they don't get paid, so therefore they want to make sure it works all the time. All right, so we're about ready to close up. Again, I appreciate your time, I appreciate your patience. Please tune in again. We're going to be doing this once a month. This is our third in a series. We're going to do 12 of these series, and I hope they have added value to you. I hope you have learned something. And please, contact me. Let me know what you think, because I'd like to be able to answer your questions and your concerns during the Sunny Asset Tour so that we can educate you and you can make an informed decision. Again, my name is Chris Schuring, and I appreciate your time and your patience. Have a great day, and we'll see you next time. Thank you.